Yeah, hello everyone. Thanks for joining our live panel discussion at LinkedIn and YouTube here about the communication of sensors in the future. I'm Frank Nolte, Deputy Editor-in-Chief of the automation magazine ETZ at the VDE Verlag, and I'm very proud to host this panel discussion here today. Here on the panel, I have 4 experts joining me to talk about the different technologies like IO-Link, SPE, and sensors to cloud. Now, please let me introduce my guests. First, here is Ralf Moebus. He is Head of Production Management Industrial Communication at LAB and an expert for cabling and connectors. He represents also the SPE Industrial Partner Network today. Next, Frank Moritz. He is not only Technical Industry Manager at SICK, but also Head of Industrial Working Groups in organizations like IO-Link, PI International, and ODVA. SICK is also founding member of the Single Per Ethernet System Alliance. Next is Peter Wienzek. He is a Manager Business Development Systems at IFM Electronic here in Essen. Thanks for hosting this event, by the way. And Peter is specialist for sensors and communication technology. Last but not least is Wolfgang Wiedemann, Head of Application and Sales Support in the business unit Automation at Moore Electronic. He is a specialist for distributed automation technology. So, before we start our talk about what the communication between the sensors and control level will look like in the future, I want to invite you to ask questions in the chat, and they will, the techniques will present them on our screen, and we will directly put them into our discussion. Sorry. So, over the last decade on technology, one technology has been established as the digital standard for sensors. In the field area, mainly because it makes installation easy and uses a simple point-to-point communication. I think all of you know what I'm talking about, it's IO-Link. But will it also dominate the sensor communication in the future? Even as the automation pyramid has dissolved and IO-Link has 1 or 2 restrictions, sorry, example for length. What do you think about?
Yeah, for sure, you're right. So IO-Link for the moment is restricted to a length of 20 meters and has not that highest speed approach modern communication may expect. That's right, and but I'm pretty sure that the IO-Link interface itself, as a, I want to say, low-cost interface, will move in the next step to a more potential physical layer, which also can be single per Ethernet as a base, and therefore extend the length as well as the speed you can transport over this medium.
Okay, Ralf, what do you think about IO-Link? Is it really the technology of the future?
Yes, I think so. It is also technology of the future because let's say the application that IO-Link was developed for, I think it has a perfect fit for these very simple sensors. And yes, since it has some limitations, you mentioned it is limited to 20 meters and it's always a star topology. I think there may be also in future with new applications coming up and maybe also new sensors are coming up for new applications like predictive maintenance, like AI, artificial intelligence, where we need maybe more data from the sensor in other systems, and then we maybe need also different communication technologies. And so the question for me is not, is there still a market for IO-Link in the future? The question is, what will be the new applications that are coming with smart factories and Industry 4.0, and where we maybe need also new technologies? Yeah.
As you said, the sensors develop the communication, the informations to higher levels. How important is it that sensors should communicate directly into the cloud? Wolfgang, what is your opinion of that?
I think it will be in the future very important because we see that when we visit the customers want to talk with us about to have current in the cloud from sensors, to have information if the sensor is ill and not die or things like this. And this will be very, very important for the future. But it will be also interesting to see what kind of information we need in the cloud. I think it's not necessary to have all information that a sensor can give us in the cloud. I think we have to look for the smart information, smart data, and not big data. Because when we fill a data lake with all sensors, when you think about application with 1,000 sensors and you put all data somewhere, it will be perhaps a little bit difficult. And this, I think, is for the future one of the important things, to find out what we need, and then we look for the right communication.
Peter, EFM has also has already an IO-Link a cloud solution. What is the questions from the users? Do they use it already extremely, or is it just developing?
I would like to differentiate different markets. I think different markets have a different, let's say, level of acceptance of cloud technologies. And I'm responsible for the Asian market as well, and I could see the acceptance of cloud technology in Asia was much earlier than, especially in Germany. Yeah, somehow I have the feeling there is still a little bit of German angst that we have from time to time. It's changing. It has changed also during the pandemic, but people in Asian countries, for example, or in Australia, we have done, I think, our first cloud application we have done in Australia. Yeah, customers were very open to these new technologies. But what is also important, and I agree with Wolfgang, is to make sure that you have the right information in the cloud, and not everything. And this is a weakness when you start talking with customers about cloud solutions. That they in the first run, it's difficult to find out what is the really beneficial information, what is the smart information that you need in the cloud, and therefore one of the ideas is to have a smart edge gateway in between, as a, let's say, IO-Link to edge gateway to cloud. And this edge gateway could be the data aggregation unit in between.
Yeah. So we got a question from LinkedIn. When there is an end-to-end communication from sensor to cloud, how can IO-Link resolve the issue of cybersecurity and secure communication? That's very interesting. Yeah, for sure. Security is a very important question and a topic. Ralf, would you answer that?
So you mentioned it. You are thinking about a cloud gateway, yeah, where you connect the IO-Link sensors. In this case, for sure, I think it's part of that. Needs to be part of that cloud gateway to have security mechanisms implemented. Yeah. So at the end, if you're talking about that topic security, it's always important which device has the communication channel to the cloud, yeah, and so could be an IoT gateway, but if it's directly implemented in the sensor, that interface that goes to the cloud, yeah, then in this case we maybe need security mechanisms then integrated there. Yeah.
Okay, Frank, yeah. Is IO-Link already ready for security mechanisms?
For the day, I want to say no. So at the moment, IO-Link is a basic communication protocol and has not this encryption, I want to say, which you need for security. But that is not the real problem, because for now, IO-Link is on a length of 20 meters, which is really locally and restricted. And on the other hand, IO-Link itself, if we talk about the protocol and the data, how they are coded over this protocol, this is, let's say, an own protocol which is not routable. And therefore, it's not an issue that it can be attacked by security issues like you have on the Ethernet, let's say TCP/IP level. So just I want to say, IO-Link is not that sensitive to security issues and security risks for the moment.
In short words, IO-Link is not TCP/IP based.
That's right. Yeah.
And that is a big advantage when it comes to security.
Okay.
And I agree also. I think it's like I say, if someone attacked, we have to protect it more open, not on the last meter, on the last step. We have to do the security in a higher level system.
In the edge gateway.
Perhaps in the edge gateway, or perhaps in
on
some masters or things like this.
Yeah.
Okay. So back to the sensor to cloud communication. How is it? I think we as you mentioned, it's useful to collect the data and prearrange the data and to count the data in the field, like in I/O modules, intelligent I/O modules or something in the field, instead of put anything, any sensor directly into the cloud, isn't it? Or we should use intelligent data, smart data, as you said, and not big data. Not every sensor needs a intelligent network to communicate directly into the cloud, isn't it, Wolfgang?
I think it's exactly what you say, that we need some middleware, perhaps the I/O modules, where we transfer the data via OPC, UART, JSON, MQTT to higher level systems. And this is the important thing. And then we can decide what we want to send up in the cloud. And this will be for all from us the future, that we transfer the data. Because the good thing is that we, in IO-Link, we have a connection, we have no addressing end. So if we want to have sensors, they are very intelligent and send up data, we have also to address them. We have also to do all the IT things that we need. And I think there will be some sensors for the future, clear, that need a communication direct to a cloud with IP addressing end. But a lot of sensors will be in the way that we have in IO-Link, that we connect it point to point and it's running without addressing and all the easy things.
Yeah.
I want to add an important point. Let's say the most people working in the automation field, so our typical users of our sensors, are not the IT expert today.
For sure.
Yeah, that is. I think that's also an important point. Yeah, we can have the most beautiful IT related devices with SPE and TCP/IP. It can be connected directly to the cloud and so on and so on. But you have to have an extremely higher knowledge of IT that most of the people do have today. And the nice thing, I agree with Wolfgang on the IO-Link side, is you don't have to take care of IP addressing and all these things that make systems more complex. We have a strict plug-and-play system. So that means everybody can replace a sensor in case of emergency, even in the night shift. Yeah, you don't need experts.
And to connect the every sensor to the cloud, you need intelligent interfaces and expensive interfaces. And therefore, I think it is not necessary to connect any sensor to the cloud and to put a high expensive Ethernet or field bus interface to any sensor, isn't it? What do you do at EFM?
Expensive is relative.
For sure.
Yeah. So yeah. So if you one of the ideas behind, there are many ideas about what applications we run in the cloud, but one of the most important thing is real-time maintenance. What we offer in the cloud, and that means that the customer can earn dramatically a lot of money when he can do the maintenance in advance and avoid unexpected breakdown. And in this case, if the customer can earn, let's say, 100,000 euro per day, or in the automotive industry sometimes per hour, yeah. What is expensive for an edge gateway then, compared to that amount?
Okay. So we got a new questions from our audience. I think it's for you, Frank, again. It's IO-Link Wireless. Is IO-Link Wireless seeing tractions in terms of vendor and customer adoption?
Yes, for sure. For today, we see already real companies, machine builders, mainly in the area of robotics and of arm tooling, using already this technology successfully. So for me, it is been in the market and it's working, yeah. And there is adoption of customers.
But there are not as many products in the market, or yet. EFM, do you want to say something when EFM is presenting the first IO-Link wireless products?
We are definitely working on that, as I think most of the other companies here in this round as well. The story is that let's say it's always when you want to make the best and most the best wireless application for this particular application, then you have to put a lot of energy also in making the EMC resistant and things like that. And this is something that takes a while to develop. It definitely will come, but I think all of us, the typical IO-Link suppliers are not the typical wireless suppliers. And that means there is a new technology coming also into our development, into our production, and we also have to learn how to do it in a correct way.
Yeah, and it's a special market for sure.
Yeah.
Therefore, yeah.
And I think for sure IO-Link IO-Link wireless is a very interesting radio technology for the field level, which is specialized for that applications to work there. But what I also see, what is still missing with all the wireless discussions, also if we think about 5G or such things, it's still the power supply that is missing. So that means you still need always a cable to bring the power there, because no one wants to replace batteries in the night shift or something like this. So this is, I think we agree. Yeah. So you always need a cable, sure. And this is where I think also single pair Ethernet now gives a new opportunity with PODL, power over data line, where you just need two copper cores to bring the data and the power there. Yeah, no additional cable, and that's, I think, a more interesting technology than any other wireless technology for sensors in the field level. Yeah.
IO-Link is doing the same thing. One cable with energy and data.
Yeah, you are talking about IO-Link. This question was about IO-Link wireless. Yeah, right.
So as you mentioned SPE, that will be my next question. It is often discussed as the technology to bring Ethernet communication down to the field level. But is it the last word of wisdom, especially in the future?
I think perhaps it will be a combination, because if we talk about SPE, it must be seamless, that it works very, very easy. And this is the question, what is going on there? If it works, you can connect a sensor to an edge gateway, and it's a seamless communication without any parameterization and a lot of things, then it will be also a good idea. But like we talked in the beginning, I think we have to think about what can be in the future for the customer the right things. And I think a lot of different informations will be for the customers important. So that we have IO-Link, it's clear, because we see the growth in IO-Link, it's unbelievable. And also there will come some other things like wireless, some SPE, yes, but at the moment the market is running in IO-Link, and I think IO-Link has also, like Frank can tell you also, that IO-Link is going in the right way to do a little bit more, to go in the way to combine perhaps SPE and IO-Link.
Yeah, but first let me ask another question about SPE. I think isn't it a problem for the market that there has been established at least two, now three different kinds of connectors standardized? It's 4. In the meantime, 4. Okay.
One yeah. 20 as well. don't forget the 20 connector.
Especially as both of you, Ralf and Frank, represent two of the big SPE associations. Why do they have some different standards of the connectors?
I think, first of all, it's a normal process that connector companies are developing connectors that they bring then in the standardization. Yeah. So now we have different standards in the standard. Yeah. different connector standards. So,
Yeah.
but at the end, it's also important the market which needs to decide which connector standard is used. So, you know, we have a lot of norms where different standards are, but not all of them have a market relevance. Yeah? And so I think at the moment we are in this status that we are in the discussion which connector standard shall be used for different industrial protocols. For instance, for Profinet, or for instance, for Ethernet IP at the ODVA in the PI organization. So, and I think there's a process started where we now want to have a decision on a certain connector standard, especially at the ODVA for Ethernet IP, and then the target is to have one single connector, yeah, that can be used. And this gives a clear user guidance. And also, I want to mention that at the end, I think if we end up with maybe two different connector types, I think this will not mean that we cannot use single pair Ethernet. It's maybe from a customer perspective or a user perspective, not the best case, but still the market can decide. Yeah.
Okay. Frank?
Yeah, well, if it comes to market, then I want to differentiate between what is, let's say, factory automation and the field of a factory automation, or let's say another market for SPE could be the building automation. And it makes a lot of sense, or I think it can make a lot of sense to use a different connector for the building automation or IP20 connections versus the IP67 typical connections in the field. And what I want to say, if it comes to connectors and cables and let's say communication to sensors like the IO-Link itself as well, we do not forget, or it's not a good idea to forget the power supply and of such sensors. So for IO-Link, we know we have a one cable solution, power and communication in one cable, and SPE is also providing the same with a poodle. But in some cases, that's not enough. Think about an actuator, not a sensor, but you have to switch off a second supply of it. And then my feeling is it makes a lot of sense in practice to have a connector with also, it's called hybrid connectors, with an extra power supply. Beneficial thing is that you have only one cable and the power combined to the communication. At the end, this I think reduces costs in wiring and efforts.
Okay.
So,
Peter, as you mentioned, there are 4 standards now. What is your opinion in this way about the connectors?
As the IFM perspective, I'm looking a little bit like a bird view on what the different standardization groups are doing. So we are not part of them. We are just waiting. Let the market decide, as you mentioned earlier. Let the market decide, and for us, we see SPE for the moment as a northbound connected to our IO-Link masters, and therefore we do what the customer wants.
Yeah, for sure. I think everybody does. Every company does that what the customer wants.
But what is important, just to differentiate between the, let's say, different performance classes.
Yeah.
I would call it performance classes on the sensor side. Yeah. At the moment, let's say at the moment, IO-Link can be used for the lowest performance class as well. So we have proximity switches with IO-Link, but I don't see proximity switches with SPE, for example. Okay. That is overwhelmed for it. And so what we are doing in the IO-Link group is trying to bring the best from the two worlds. So having IO-Link communication on a SPE-like cable, yeah, but keeping all the good things of IO-Link, like plug and play, no IP addressing and stuff like that. And on the northbound of the IO-Link master, yeah, we are flexible. We can do whatever we want. But what is important to us as a sensor manufacturer with couple thousand IO-Link sensors, we cannot follow all the connector standards on our sensor side. So we have to keep it on one standard.
Great that our audience is taking part of the discussion. It's a new question here on LinkedIn. What do you think needs to be done to simplify the commissioning of IO-Link masters As a sensor providers, how do you support with developing the functional block for different PLCs to support the IO-Link integration? Wolfgang?
I think that's a question for me also, because I'm looking for the standard for the profiles in IO-Link, and I think it will be more easy in the future when we work with profiles like the smart sensor profile in IO-Link, that we have the same process data from measuring sensors, and it not depends which kind of sensor it's from factory A or B or C. If we have the same process data, so it will be more easy. So you have not to do a difficult commissioning or something or parameterization. So you can plug and play the sensors. You only need 4 IO-Link bytes, and then you can send out the data in the same way. And that must be the way. So we're working on a lot of different profiles now: smart sensor profile, lightning profile, power profile, RFID, and so this will be a very important thing. And we know exactly in the IO-Link community that this is I don't want to say a big issue, but this is an issue for the customers sometimes to handle all these things, and also different kind of PLCs and different kind of masters. But if we find a standard, then, and we work very hard on this standard, then it will be for the future perfect.
Before Frank and Peter say something about it, we had this interview last year about the profiles. I remember that if the audience wants to know more about it, read the ETZ. And but when will the profiles will be available?
So the smart sensor profile is available,
yeah.
And we think that we have the actuator profile this year. At the end of this year, and so it goes step by step. But it's it's very difficult sometimes to work on profiles. It's exactly what we see in the cable, in the connection. There are some factories and they want to have their ideas, and we have to put them together and find a way. This is the success for IO-Link, that we have the only standard in the world to communicate. And so we look at also now in these profiles, and it takes a little bit more time than we think sometimes to bring all together.
So back to the communication, please. The sensor guides.
Well,
Frank and Peter.
I want to mention for to simplify the commissioning of the IO-Link masters, that is an issue about the tooling you have to use.
Okay.
And very often today you have to use 2 toolings, one from the tooling engineering tools for the PLC itself as well as for the IO-Link master. And one approach to simplify this is, or could be, to combine these both toolings. Like for the Profinet world, you have this GSD file that you can maybe integrate the IOTDs of the sensors and to the GSD of the master, and to simplify the commissioning in that way. So customers have only to use one tool to what they know. On the other hand, there was the question about I think function blocks. Which is not, for me, it's not commissioning, it's accessing data for the runtime. And therefore, 2 things I want to mention. One thing is that for the profiles, as Wolfgang mentioned, there are function blocks available from the IO-Link community. They are for download and for free, I guess. So this is helping. And for me, as a sensor supplier, I can say we support our customers one step beyond with a product called or a process called Function Block Factory. So users can, or customers can assign some devices to an IO-Link master, press a button, and out comes a function block, not one function block, but different function block for different PLCs. They are ready to use, and then it's very easy to access all the data.
Peter, want you add something, or should we go to the next question?
No, I fully agree. Just a quick add-on. The nice thing with IO-Link is that we standardize more and more. Smart profile is a very good step. The IODD is a standardized format. And the nice thing is that we are not only a consortium of sensor companies, we also have the leading PLC companies in the group. And to me, it's always the most convenient way if the PLC company supports the profile. That is of course it cannot be realized all the time. We have to support the customers as well with some specialties. But of course, as a really plug and play solution, the best thing is if the PLC supplier is doing that, of course.
Yeah. So next question from LinkedIn. Can we eliminate the process control by directly connecting to cloud and keeping only ESD and sys in local? Frank?
So maybe I'm not aware with the ESD and SAIS in local with that term. But if the question is, can we eliminate the process controller, which means the PLC, I guess on the PLC level, and controlling everything from the cloud, I want to say yes, that could be possible if it comes to non-real-time automational tasks, which are very slow. But if it comes to these, you have to operate a machine and to react in 20 milliseconds or something like that, then the latency time transmitting the data to the cloud and up and down is too long. So.
But perhaps for predictive maintenance to control perhaps a temperature, and we want to give an alarm message to an iPhone or a mobile phone, that will be possible. So you can send the data directly to the cloud, you can handle them in the cloud, and then you can also give some information. It's like Frank said, if it's not in real time, then it's possible now.
For sure. Yes.
Depending what you understand under process control. If you really mean hard process control that as a replacement of a PLC, then it could be critical. But this is one of the approaches that we have together with the 5G technology. 5G in the next evaluation step should have these capabilities to have a, let's say, a delay of maximum 2 milliseconds. But at the moment, it's a dream. This is on the agenda, but still ongoing process.
Yeah, but we think about communication of sensors in the future. Therefore, so another question. Now, any strategy to use satellite backhaul when you don't have cellular backhaul or when it is flanky? That's a tough one.
I can say we have done some satellite application, but that was in the outback in Australia where you don't have any other possibilities. So it was not a backup. It was the only connection technology. For example, if you have a remote pump station somewhere in the outback where they pump the water from the center of the country to the coast where the people are, and therefore. Satellite was the only way, but you know, from let's say from our sensors, from our IO-Link communication technology, from the IO-Link master, from the edge gateways, we don't care where we connect it to. It can be a local Wi-Fi, it can be 5G, it can be 4G, it can be any other mobile communication.
So as we
talk,
talk,
was not a direct answer to the question, but. At the moment, I don't see the backhaul.
I think it's the same. Although,
I agree.
Technically possible.
Yes.
So as we talked a lot about IO-Link and SPE, wouldn't be IO-Link over SPE, or which is now called IO-Link Plus, I know, which has been a concept study in 2021. Wouldn't that be the ideal solution for sensor to cloud or sensor to upper level communication? Was it?
Yeah, I mentioned earlier these different performance classes on the sensor side, and at the moment we think the class 1 and class 2 we can use with the existing IO-Link technology. With COM3, for example, there is a more higher performance port, but there is still a missing part on the class 3 side where customers say we like all the benefits of IO-Link, but we don't want to have Ethernet connected. That could be, for example, RFID. Our IO-Link RFID system is a high runner at the moment, but people want to have more and more data in the RFID tags, for example. In the past, it was just a few bytes, That is not a problem at all. And now there are customers that say we want to have part of the process of the actual process stored on the tag. So it could be a couple hundred bytes, and therefore in more or less real time. And that means therefore our performance class 1 and 2 is not enough, and therefore we see a new performance class 3, which could be based on, let's say, I always say on the SPE cable, and using a modified IO-Link telegram on this cable.
So just IO-Link Plus will be just a different technology on IO-Link, like IO-Link wireless and IO-Link safety and sorry.
But we are talking. We are looking at 10 times more performance.
Yeah, for sure. And you don't have the length length description now. You have
the length will be increased as well.
Yeah. But why do you use IO-Link Plus? I think it sounds then is IO-Link then minus?
No, because it's in many magazines. I'm not talking about your magazine, but in many magazines we see there is a lot of confusion on SPE and IO-Link over SPE, and people think when they hear IO-Link over SPE that is also TCP/IP technology and IP addressing and things like that. And we want to avoid that. We want to keep all the benefits. Wolfgang mentioned earlier the benefits of IO-Link, the easiness of IO-Link, and open it to a higher bandwidth, to the next performance level. That's the idea, and that's why we said let's keep it in the IO-Link wording as a new IO-Link interface.
And only perhaps one comment to the cabling also. It will be also very important that we have not shielded cable in IO-Link. This is also a part, because if we take shielded cable, then for me it's clear shielded cable is Ethernet communication, and non-shielded cable, the benefit of non-shielded cable is IO-Link.
Okay, Frank?
And one beneficial thing I want to say is we always talk about sensor to cloud, that's clear, but that's more than only a cable or a special technology like SPE or IO-Link. But it's also about the protocols we are running or the language we are talking about. And if we go now for IO-Link over an SPE architecture cable, we have higher speed, longer distance, that's right. But what we also have is, I want to say, it's the ecosystem of IO-Link, which means the description of the devices, the integration into engineering tools, the adaptation to all the different field bus worlds and PLCs. And that is a real benefit also for IO-Link running over an SPE cable, I want to say.
Ralf, want you add something?
I agree with that. Exactly, you have already an ecosystem available, and I think that could make the migration path to SPE for sensor manufacturers more easier, because you can use a lot of things, the complete application layer, let's say it like this, and single pair Ethernet does just define the physical layer. Yeah, so to change the physical layer, maybe add some protocol things like addressing or things like this. Yeah, some things need to be defined, but then I think it could be for the existing sensors and ecosystem, it could be a good migration path. And maybe for more complex sensors, which should directly communicate to the cloud, we maybe need something different, like, I don't know, OPC-UA or something like this, which have also security mechanisms implemented and things like this. Yeah, but what the definition, we did not define it really, what is a simple sensor and a complex sensor. But for me, a complex sensor is maybe a camera, or maybe also a measuring light curtain or something like this, or a QR code reader, which is has more data to provide than just on-off.
Yeah, sounds like a good idea and a good theme for another panel discussion. Thanks a lot for joining. It was a pleasure. Thanks a lot for all the interesting questions, and thanks for your attendance and your interesting answers. I think there are, to find a fulfilling statement, there are a couple of communication technologies to make data seamlessly available through all systems, but there won't be only the one solution, and I think it's good in this way. I think nobody wants a monopoly, and so the that would not be good for the market development when there is only one supplier for anything. And so the communication has to be as flexible and varied as the machines and the requirements of the end users, so that you can fulfill any wishes of the end users. And the markets are very different, as we've talked about. And thanks a lot for joining. Have a good day. Thanks. Bye.